So we're at the Splash conference in Amsterdam, and I'm here to interview Benjamin Pierce, professor of computer science at the University of Pennsylvania in the US. So welcome, Benjamin.
Thank you.
So you've given a keynote here yesterday, and was mostly about your new project called Deep Specification. So can you tell a little bit about it and also why it's important?
Yes, my colleagues and I are very excited about this project because it's a chance to greatly increase the momentum of something that we see happening very much already around the community. The area of specification and verification of software, as you know, is an old one, going back almost to the beginning of the field. But we begin to see in the past 10 years or so various point efforts here and there, very heroic, to succeeding in verifying large industrially relevant pieces of software. Those efforts are still rather separate, and we see this project as an effort to bring them together to create momentum in the community for weaving together projects in specification and verification at a large scale, and learning about the science and engineering of formally specified and verified software.
So thank you. So if I understand correctly, one goal is to formalize and verify the whole software stack, from the hardware to the operating system to programming languages. So do you think that this will have impact on the way we do programming or software development in general in the mainstream industrial settings?
Well, I certainly hope so. Our vision, I think, is that, of course, verification is going to remain somewhat expensive. We don't see that all software will be verified in the future. What we see is that critical software, the software that runs the operating systems, networks, compilers, and so on, will be verified and will be, to the extent that the specifications are complete, 100% free of bugs. And this is really necessary. This is the only way that we can move forward into the kind of information society that we're creating. On top of this critical layer of software will be much, much more software written not in the unsafe, low-level languages of today, but in safer, more powerful, simpler, more expressive, high-level languages, where the kinds of low-level exploits and bugs that are so easy to find in today's systems are simply not available by construction.
So a large aspect of this approach to software development is around the tools to do the verification and to check the proofs. And so there are many tools out there, mostly designed in academia. Do you expect that they will become more mainstream, like integrated development environments have become completely mainstream?
I do. For example, in hardware design, formal specification and verification is already ubiquitous. You find it everywhere. The reason is that hardware is very important and very rigid, very expensive to correct a mistake after the fact. So people use these tools, they're motivated, and they've found ways to integrate them into the hardware development process. And that's just the way business is done in that area. I expect other areas to follow suit gradually as the tools are better understood and become more mature.
So if I'm a company that is in the critical software sort of business, and I want to make my software more trustworthy. So where do I begin? What are the first steps that I should explore to start, going towards this verified software?
Begin with the specifications. Verification is nice, but expensive. Simply the act of writing down a specification, not in informal prose, but as a formal, perhaps executable, detailed, rigorous structure, is already a huge amount of the benefit. And we have now automated testing techniques, including property-based random testing, concolic testing, model checking, SMT-based testing, and so on, that are capable of using specifications to achieve perhaps not 100% confidence, not the same as a end-to-end proof, but extremely good confidence, much better than what's available by simpler techniques, such as unit testing. And for many companies, these simpler techniques will be enough. But in any case, focusing on getting the specifications right is the first step toward proving anything.
But many of those companies, well, many companies in general, they are already they have developed lots of software, right? They have a legacy base of source code or deployed user base. So, does deep specification or this approach to software development require a greenfield situation, or is there a gradual path towards, gradually introducing trustworthy components in your existing landscape?
Well, as you suggest, we can't obviously replace the entire software ecosystem all at once. We need to focus on the components that are most critical and the components that are most likely to be wrong. So those are the lowest level components in the software stack, the operating system kernels, and so on, and also the most security critical ones, for example, the cryptographic algorithms and their implementations.
Okay, so final question. In your keynote, you also sketched some directions for how the project, Deep Specification project, will have influence in education. So can you briefly tell us a little bit about your plans?
Yes, education is a very large part of the DeepSpec project. We see it happening at several levels. So one very important thing is that at the undergraduate level, we need to train people to think rigorously about the specification of software systems. At the moment, the specifications that undergraduates are asked to deal with are very informal, and even at the informal level, the emphasis is usually elsewhere. It's on getting it to work, whatever that means, rather than what does it mean that it works. We need to change that, and the way to change that is to not, once again, throw everything out and do it again. We need to change it by injecting rigor into the courses that we have already. So we're aiming in the DeepSpec project at two courses in particular, the undergraduate compiler course and the undergraduate operating system course. We would like to offer drop-in replacements for the existing courses that can be used by in any existing curriculum structure that offer the same things to the students, but with a degree of rigor and with an exposure to the specifications, not of course the formal proofs, but the specifications of the components of those systems that will allow them to see it in a much more precise and careful way. At the graduate level, we need to teach people to actually specify and verify critical system software. And these courses are being taught. What's needed is to bring the materials together and make them available on a large scale, and this is something that we hope to do through the materials that we will publish and the textbooks that we're writing.
Thank you very much, Benjamin. So this concludes the interview with Benjamin Peers at SplashCon here in Amsterdam.